Welcome, dear students. We are in the fourth lecture of managing software projects. We shall see in this lecture about the revision. The first is software metrics that we saw in the previous lecture, where we saw it's a degree of measurement. We saw that we are able to measure product, process, and project using metrics. We next saw size-oriented metrics, where we are counting each and every line written in the editor, which is a part of a code, apart from comments and blanks measured in line of code, and they are generally counted in form of 1,000 lines of codes. We saw that it is very easy to do this, but it is language specific and it penalizes well-designed programs and it is not universally accepted. So we went towards function-oriented metrics, where we saw that it is dividing the system into 5 different functional units, and based on these units, it is founding the FPA, that is functional point analysis, using unadjusted function point and complexity adjustment factors. We saw how we are calculating this with the help of an FPA matrix, and we found what is function-oriented metrics using this significance value and the questionnaires. Okay, so today we are going to see object oriented metrics. Now object oriented metrics is widely used because the previous ones, that is LOC and FP, had a problem. They were not providing enough details or granularity for schedule and for effort adjustment, because they were not helping us to find a schedule, they were not helping us to estimate efforts. So if you are supposed to deliver an software incrementally or evolutionary way, then these both will not be helpful to you. So you have to move into object oriented metrics. You can obviously use this metrics if you are planning to develop through an object oriented approach, otherwise it will not work. Here it works on basis of scenario. Now what is scenario? So scenario is nothing but it is formed into triplets. So scenario is your use case. Use case is the features of your system. So features of your system are initiated by someone, some response is given as per action, and participant is the one who is helping to complete the whole process. So every scenario is listed into triplets, that is initiator, response, that is action, and the person who is helping to successfully do the scenario. Next is you are identifying the key classes. Now what are classes? Classes are highly independent components and they are defined very early in the project. Now if they are defined early, it becomes very easy to know how much effort will be needed for coding and how much code you are able to reuse. Next is the number of support classes. Now what are support classes? They are not the main classes, but they are classes which are helping you in order to do the work for the main class. So they are support classes required to implement the system, but they are not immediately related to the problem domain. So let us take an example of our cardio health monitor system. In the class diagram, we had a client as a main class, okay, but it had a country class as a supporting class, because where he stays we had divided into a country class. That is why it could be a supporting class. Now supporting classes can even be GUI, they can be databases, they can also be the country class which I gave you as an example. They will also indicate how much effort you will have to put in and how much of code could be reused. Okay, now you are also finding out how many average number of support classes per key class you have. So in client management, you had one support class, that is country. You may have more than one in other cases. So you will find out that number of classes and you could give a rough estimation of how much effort you will need to put in and how much code could be reused. And number of subsystems. So subsystem is nothing but an aggregation of classes. So aggregation of classes is nothing but you are having a class which is having another subclass inside its part of that class. Okay, so if I'm saying a document, then a paragraph will be something inside a document. Okay, so it is talking about these kind of subsystems. So if a project has such kind of subsystems, then it is partitioned into those subsystems and given and distributed among different staff members. So this is how object-oriented metrics will work. We shall now move on to use case-oriented metrics. Now use case, you already know they are nothing but the domain requirements or features or functions of your system. We took an example of taking tests or managing reports in cardio health monitor system. So all the ellipses that were there in my system were my use cases. So these use cases are also defined very early in the process, and due to this you can significantly reduce the time used in estimation, reduce the time used in coding, reduce the time used in design and testing. So all the phases you can estimate very early before you initiate your process. There is also a SAID method or a SAID mechanism, UCP, that is use case points. Like you have function points, you also have use case points. It is almost similar to function points, and it is also used for estimating the project effort and other characteristics. Now, advantage of use case oriented metrics is it is independent of programming language, and the number of use cases which are there in the use case diagram is directly proportional to the size of application in the LOC. This is what it says, that it happens in this way. Number of use cases is proportional to size of application in the LOC and proportional to number of test cases that you will have to design in the application. Now, disadvantages that use cases are created at different levels of abstraction. So if I'm talking about, if I just keep a use case account management, then account management can be you are either deducting money, you are adding money, you are just checking balance. So if I'm not showing these things in detail, if I'm just showing account management in for banking, then I won't be able to give a complete estimation of the size of my software. Next is COCOMO, that is empirical estimation model. This is a model which is widely used currently and most important for GTU purpose. COCOMO is nothing but constructive cost model, and we will see all about COCOMO model, its types and modes in the next lecture. Thank you.